Assalamualaikum warahmatullahi wabarakatuh. Welcome to this video. This is a presentation for the Digital Signal Processing Project.
Okay, my name is Muhammad Amirul bin Muhammad Yusof and my metric number DE170129.
Hello and hi, my name is Muhammad Najmi Zikri bin Nazri. My metric number is DE170140.
Hi, my name is Iskandar Nakudin bin Muhammad Isham. My metric card number is DE170158.
An electrical signal frequency spectrum is the distribution of each frequency component's amplitude in phases against frequency. Due to the smaller antenna size, the enhanced directional effect of the antenna, and the broader frequency range available, the use of higher frequency is desirable. And a full range device is any audio device capable of capturing, producing, or processing the entire 20 Hz to 20 kHz audio frequency spectrum. An electrical signal frequency spectrum is the distribution of each frequency component's amplitude and phases against frequency. For this project, we had record data of our voice saying UTHM FKE using MATLAB by using function with record, and we also calculate the spectrum of the decimated signal using track transform technique to plot the magnitude and phase spectrum of the signal.
Hello and hi, my name is Najmi. For this part, I will explain about the methodology for this project. So basically for this project, our team will use the MATLAB software. So the MATLAB software is the software we use this project. The software use to calculate any calculation that necessary for any engineering problem. In this project, MATLAB software has been used for design and simulate code for recording voice data with set UTHM FKE using wave record function, and then the spectrum of data can be analyzed. So basically, according to question that we need to record our voice by say UTHM FKE. For this, we need to use a wave record function for record our voice on MATLAB simulation. So lastly, by using MATLAB software, we can decimate the recovered data by 500 and amplify it to 10 beside decimate signal spectrum using Z transform technique for plotting the signal magnitude and phase spectrum. So next we go through the flowchart for this project. First is start, and second is design and simulate MATLAB code to record voice data with set UTHM FKE. After that, we need to simulate the voice, and if a voice success, we go through the design and simulate MATLAB code to retrieve the word M signal from the voice data recorder. For this part, we need to find the word M from 5 seconds of the total of the UTHM FKE. So after that, we need to simulate the signal. After simulation success, and next we go to the design and simulate MATLAB code to decimate then retrieve data by 500 and amplify it by 10 and plot the signal. After find the signal and the plotting, and we go and then design and simulate MATLAB code to plot the magnitude and phase of the signal. After find the magnitude and phase signal, we need to plot the graph. After that, the project is end.
Okay, for the first question, we need to record the UTHM FKE voice. So the step, firstly we need to write this thing. audio recorder as A, and the frequency 11,025 Hz, 8 bit, and we use 1 for their mono here, and then we record our voice here, record A5, and 5 for 5 seconds, and then from the record that we get, we put the record information into the B, and we get audio data A. So we can try it, sound B, and we plot their graph. So through here,
UTHM FKE.
so this is the graph from the voice, and then we save the voice into the UTHM wave here. This is their code, and then we need, for the question 1, the question asks to take the M word from the FKEE, from UTHM FKEE word. So this is the coding. We set it at M word, and the data is from B, and then we take from what time? 2 point. So I just put it 2 point, from 2.2 second until 2 second, the M word will appear. Okay, then we hear the sound of M. Okay, then we plot graph for the M. This is the coding. So this is the signal for the M. Okay, for the second question, the question asks to decimate the signal M that before this that we get by 500, and then we need to amplify it by 10. Okay, for the step, firstly we must get the M word before this that we have saved it in M wave. So this is the function. So we just read the M wave, so this information will get into this question. So now the M word will save in this, and then for the decimate by 500, this is the coding. So we just put the value, the decimate, and then 500, the value that we need, and then this is position of our graph. So we plot it as I, plot I, this is I, and then for the second graph, so this is for the first, this is a original graph, for this is original signal, and then this is the decimated signal. Okay, first we put their position, stem D decimate, the value that we get before this, the decimate. Then the graph of decimate signal will appear then, and then this is after we decimate it, we amplify it by 10. The data before D, we multiply by 10 to amplify it, and then this is coding for the graph. Okay, to see the graph, we copy this, firstly clear. Okay, we write M, we get it with M. Okay, so here we can see this is a original signal we get, and this the decimated of word M. Here we can see their range amplitude, you have 2, the higher, and the lower is below 0. And when we amplify of the D of the signal that has been decimated, the graph will show like this, and the range of amplitude will be smaller. Okay, for the question 3, the question asks to create the decimate as before, but this time we were using a Z transform method. Okay, for the simulation, firstly we need to assign the h is the decimate function, and then n is the length of the sample, and b is the data before, and z is the value that we will put into the Z transform formula. Okay, this is the Z transform formula. B is the answer for the each Z transform value. Okay, and then this is the formula. After we put it, we will display the value of Z transform. The Z transform will produce the B data. B data is Z transform value. Okay, after that we want their magnitude and their phase. So for the magnitude, it will read the h, the data from h, and for phase it will read the angle of the h. Okay, this is the coding for their graph. Okay, as we can see, firstly we need subplot 211. This is the position of the graph, and then we stamp magnitude. So it will read the magnitude data, and then this is their refer title, their title and their y and x axis, and then for their phase, this is their position, and then they will call the phase data, and this is the information about our graph. Okay, now we will run the coding. Okay, after we run the coding, so as we can see, this is the graph for our Z transform method. So as we can see, the graph is same as the before method, is same as the method that we have used before. And then their phase plot, we can see here, the magnitude here has 4 same, 3 at 3, and their sample that has 3 is 2, 8, 10 and 17. Okay, for the value of each Z transform value, we can see at here. For the formula, we will get the answer like this for their Z transform value. This is their result.
After finishing this project, the conclusion that can be concluded that this project is being resolved by using MATLAB software. We learn on how to analyze the audio signal and then how to record data of voice by saying UTHM FKEE, and the data can play back and do analysis on that signal. We managed to plot the data as stated in our result and analysis. We calculate the spectrum of the decimated signal using Z transform. We also know how to plot the magnitude and phase magnitude of the signal. All the calculations are already calculated on this software. Example, calculate the amplitude and phase. This software calculates the amplitude and phase of an input with appropriate precision, particularly in phase spectrum calculation. Overall, this project are completely finished. During the project, each group member exhibited positive attitude by contributing their best intention and energy to ensure the success of the project. The project was carried out with the cooperation of all the members of the group. Thank you.